Example 15 puts the concavity test into action again. This time we're asked to find out when the function behind me is concave up. Okay, so we know that a function is concave up when the function's second derivative is positive. So the concavity test will help us figure this out. So at this point, I'm going to ask you to pause the video, find the first and second derivatives of x, the opposite of x to the fourth plus 4x cubed minus 4x plus 1, and then unpause the video, see how you did with your derivatives, and we'll go from there. So f prime of x is going to be negative 4x cubed plus 12x squared minus 4. That's going to be used right away to find f double prime of x, which is going to be negative 12x squared plus 24x. Now we're interested in finding our possible points of inflection, and similar to the critical numbers from the first derivative. So we set the second derivative equal to 0. Right? And we're trying to figure out what values of x make that true. So let's factor this. We got two terms. Both have an x in common. They also have what looks like a 12 in common. You want to pull out a 12x? So if we do so, we have 12x, and then we have negative, or the opposite of x, left over from the first term. Don't forget that negative sign. And then plus 2 from the second term. 24x divided by 12x is 2. Right? So what are our two values here which will cause the second derivative to be equal to 0? 0 is 1, and 2 is going to be the other. All right, so we've got x is equal to 0 and 2. So let's take that 0 and that 2, and we're going to plug them on a number line and pick some test values here. Perhaps we can use negative 1, 1, and 3. And these test values are going to go into the second derivative. Okay, we're interested in signs here. We're looking for positive signs. Positive second derivative means the function is concave up. So let's take negative 1 and plug it in. We plug it in here, 12 times negative 1, that's a negative. And then when we plug it in here, we have the opposite of negative 1, so that would be 1 plus 2, so that's a positive. And a negative times a positive is a negative. Now let's plug in 1. Well, 12 times 1, that's positive, and negative 1 plus 3, negative 1 plus 2, that's also positive, so positive times a positive gives us a positive. And then when we plug in 3, 12 times 3 is positive. Negative 3 plus 2, that's a negative value. And a positive times a negative is a negative. Okay. So we have the information to draw our conclusion. We know that a function is concave up when the second derivative is positive, and we can see our second derivative is positive between 0 and 2. All right, so f prime, excuse me, not f prime, just f. F is concave up on the interval from 0 to 2, and you have to use parentheses here for concavity. You don't want to use brackets. It's got to be an open interval because we don't talk about concavity at endpoints. So we have on this interval, because f double prime is positive.